Again, see, it's quite a diverse panel, and I hope we can tie these things together to achieve something that is cohesive. And maybe again, it might just make sense to have each one of you introduce yourself quickly, and then we can go into Michael. Of course, everyone knows you well, but
Yeah, I think you heard a lot of me today already. So Michael Jacobson, president of APUA. Could also mention that I started out 20 years ago to develop and optimize the Stockholm district energy scheme. For the past 15 years, been developing and optimizing some 100 district energy schemes across Asia Pacific.
Prabhat.
So I'm Prabhat Goel, 45 years into air conditioning, still live to tell my story. And out of which 25 years I spent in the Middle East, of which probably 10 to 15 would have gone to Tabreed in putting up their various district cooling plants, including the first one, Sheikh Zayed Military City. Then you had the Manar Mall. You had umpteen numbers of them. I've forgotten the number of projects. Today I represent Eurovent in India, and it's a lovely discussion. Would love to be a part of it. Thank you.
Thanks, Prabhat.
I'm Sanjay, with 34 years of industrial experience. For last 15 years, I have been working in environment field, and most of my time has gone in development of waste to energy projects in the country. We were the first to install a Euro norm compliant plant in Delhi. Currently, I am working with a startup related with environment. We have a tech-enabled platform trying to meet service seeker and service provider together.
Thank you. My name is Ashish Rakheja. So listening to the age of 40 years experience, 34 years experience, I feel very young now with 30 years of experience. But having said that, I'm a consulting engineer, been involved in design of several large projects. And we did consider district cooling, district energy systems for many of our projects, including discussion with Tabreed. Even though I'm an air conditioning engineer, one of my mission is to work on the passive design. And I always say that minimize air conditioning. It's very dangerous to come and say that at a district cooling conference, but I still do that because that's my mission of work. Thank you.
Hi, I'm Archa. I work for Tabreed, and I think everybody knows enough about Tabreed already. Don't think I'm a fit for this panel with the amount of experience everybody has. But yeah, happy to be here. Thank you.
Great, thanks everyone. And I completely agree with you, Ashish. I think while all of us are here for a cooling conference talking about the rising cooling demand and the fact that we need to have things like this technology like district cooling and so on and so forth, nothing better than avoiding that and looking at more and more passive intervention. So maybe I'll start with you. And so from a passive design standpoint, of course, right now, there is more and more and more realization, I would say not as much as what is required, to start looking at more passive elements in building planning and design to ensure you minimize the mechanical load for cooling. But maybe both, can you just throw some light on what's currently happening in India, and then also within the context of this master plan that I just showed, how can you have it, say, for example, as a policy level or even at a master plan level, something more standardized to push for this to be done?
Is it possible I can do a 10-minute talk? That be okay?
Absolutely.
Okay,
Absolutely.
thank you.
Sure, yeah.
Thank you, Sudhir. I'll just quickly take 10 to 12 minutes to walk through the bigger picture which is there. And I know, again, as I said, my passion goes towards passive design, even though I work a lot on air conditioning systems. In fact, I've been working a lot on the net zero energy buildings. Now, we've been all hearing about the big picture which India has, and that's why we are here talking about the district cooling. We have everything right going for our, including the population, including the urbanization, including the construction sector, which will keep growing And India is promising to show the highest growth going forward, at least in this decade, when we show a growth of 14% with the biggest CAGR growth compared to any other country in the world. Because this decade, because 2030, if you have to reach the third largest economy, construction sector is what is going to drive that. Now, what is leading to that is, today we are not building buildings, we build cities. And if you look at the ports, the airports, in fact, when we announce airports, we say 150 airports will come up in the next 5 years. When we talk about ports, we say 25 ports will come up. Railway stations, 200 railway station modernization. Scales are what are changing at this point of time. Today, already the district electrical systems are a reality. Many of us at the design community, today we are working on projects we range from maybe 30 megawatts to 100 megawatts. You know, those are the kind of systems that we are talking about. There is a growing cooling demand. There is no doubt about it. The scales again have grown. Recent project that we designed was a Jewar Airport. Now, Jewar Airport had a cooling demand of 10,000 tons of air conditioning just in the current planning stage. That means when the airport grows bigger, we are talking about maybe 30, 40,000 tons of air conditioning. Residential, if you think residential is a small component, we are talking of an average project of anything between 5 million square feet to a 10 million, a crore square foot for those who come from India. This is the size of projects we are talking, and each one of them has a cooling load running into 10,000 tons to 30 to 40,000 tons. These are the scale of projects we are talking. Commercial buildings, my friend is sitting here from Tata Realty, makes an announcement, 5 million square feet, 10 million square feet. No, that's just one project from one developer. Scale is what we are talking about here. On the other hand, we have an unregulated demand growing, which is on the cooling side from the residential sector. And this is one of the stories that came in the leading newspaper here in India, which talked about an air conditioner will be sold every 15 seconds by 2037 if we continue to go the way we are currently going. Other side, we have gone and signed what we say a Paris Agreement or COP26 agreement. We said 2070 will decarbonize. Look at the pressure. The pressure is the growth. On the other side, there's a growing demand, scale of the projects, and then we're talking about decarbonization. It has to move down to interlinking the cooling demand, because we cannot go isolation the way we are currently going. Commercial will remain commercial, residential will remain residential, not going to remain the same way. We already have early indications of the district cooling which has started coming in our country. Educational campuses actually started this way. Institutions like IITs and all, they started talking about an integrated design where they said that we have a residential component, we have an academic component, why don't you look at giving us a free cooling in our residential component, because daytime you can run the academic component of it. We have today the larger campuses which are talking about it, but again, they remain isolated in terms of the usage itself. If you look at the optimal, when we look at the reducing the operational carbon, because the operational carbon is the main thing that we keep talking about, because decarbonization is the buzzword, that's why we are all sitting here. Otherwise, we'll not be here at this time in Goa, in a closed room, in a 20-degree temperature, talking about decarbonization. We won't be unless we have to discuss the larger aspects out here. And the decarbonization starts by saying, first, you look at a bigger picture of minimizing your cooling loads. You can go wrong otherwise, because the whole cost of doing this decarbonization business, whole cost of doing this district cooling, you can go wrong if you do not follow the right pyramid of the district, of the net zero, what we like to do, or the reducing operational carbon we do. We look at passive measure, we look at active measure, and finally we put the renewables and combining it with district cooling. Our energy pattern, by 2050, 70% of our energy will start going into the built environment. Look at the numbers we are talking here. And what we are forgetting here while we keep talking about district cooling is the water. I'm so happy my friend here, Anirudh Bapat, in the first panel brought this out. Think about water. We are a water-starved country. What are you bringing? Are you bringing district cooling solutions which are going to be highly dependent on water and then draw more water out? Unless you do an integrated planning, we are just talking in air, because the feasibilities will not be there. The previous panel that we had people coming from finance side. The numbers will not match unless you look at the integrated planning. And that's where our whole foundation that we have built over a period of time, the last 2 decades of the green building movement, where we today boast of a highest number of the green buildings that we have, 13 billion square feet, to the standards, codes, which we all have developed. They've given us a potential, a foundation there. Look at our daylighting potential. Where are we putting that together? My friend and myself were talking at the back. His first comment was, why are there windows, why are there no there's so much glass here, but why have they got these blinds out here? Is it for glare purposes? We got so much of daylight potential. Look at the rainfall which happens there. Where is that integrated planning, and who's talking about that integrated planning out here? And look at the renewable energy potential which India offers. Plenty of it. In fact, one desert of ours can run the whole of the country. What we miss today is an integrated approach to design, where we need to start right from the beginning. And the beginning is, that's where I'm taking my time on this one, because your case study will get supported by what I'm saying out here. First, look at the cooling demand. This is just a small project we were looking at. I'm bringing it more to a human scale, because talking of millions of tons of air conditioning, we get lost. Let me bring it down to more human scale. A small development, very efficiently designed, but what we missed was an integrated design process. A same thing which was showing a cooling load of about 2,000 tons, through an integrated design process where we are working closely with architects, looking closely with designers, we could get the cooling load down, and I'm going to skip through that because most important is showing the last bit. A building which was 100% daylit, this is about 99% daylit, to a point where the cooling load from the same building came down from 1,800 tons down to about 1,000 tons of air conditioning, which is what we need to start with on a foundation. Look at it from a township. I'm giving you a case study that we are designing. This is a 160-acre township. You spoke about a 1,000-acre. I'm again bringing it to a more human scale of 160 acres. The water demand for this township is 50 lakh liters per day, 5 million liters per day. Where are you going to get this water from? Who has thought about that? And this is a residential township with a commercial component. The wastewater that comes out is 27 lakh liters. For our friends for international, 2.7 million liters per day goes into the drain, which comes out of it. Who has thought of the integrated planning out here? Just by turning, and this has a power demand of 32 megawatt, this project. Just by getting it right, what we could have done here is that excess water which is coming out could have easily been looked at a district cooling systems, and that's where we did not do that. One of the things, again, which is being completely neglected is the heating. This is what we work on. We talk of heat pumps as if we have arrived at a mantra which is going to solve our problems. All the problems are gone. Everywhere in our country, in peak summers also, we love to have hot water bath. This is a reality. Mumbai, Pune, go around it, this is what we talk about. We have never thought about using the waste heat. We have never tried to put that together. This is a project we are looking at 100% of hot water generation being done through waste heat, which is what the air conditioning system can provide you. So this is where I wanted to go. A need is for an integrated planning, which is what is missing at this point of time. The time is right. We have solutions like waste to energy available. We have microgrids available. We are talking about distributed solar on our projects. In fact, a project in Delhi is today being designed for a 13 megawatt, 13 megawatt on-site solar being done, but no district cooling. A distributed air conditioning. 13 megawatt on-site solar, net zero energy, but at fully integrated solutions are missing. Water management, nobody is talking about, because when you put all of it together, suddenly you have a viable solution, which is what is going to make the district cooling right going forward. And that's what I think Anirudh was connecting. And thank you very much. I'll end there, but I do want to make a point where Tarun said in the earlier panel, he said, we cannot live without air conditioners. I would like to challenge you, we can live without air conditioners. We have a building in Delhi where 50% of the time we live without air conditioner and it works there. So we'll talk about it some other day. Thank you so much.
Thanks for that, Ashish. I think great context. And yeah, a lot to think over, but just trying to bring this back to the project at hand. So had that, whether through mandate, regulation, or through awareness and all actors working together, incorporated a lot more of these passive elements into the master planning aspects? I know I'm putting you on the spot, but I mean, any rough rule of thumb in terms of, say, from a power demand standpoint and a cooling demand standpoint, what could be the potential reduction? 20%, 30, I don't know.
I would dare say even 50%. If you get the factors right, I would say 50%. And this is what we have seen on actual project design.
Sure.
A well-designed project, first of all, you're able to do with a good passive design, bring the loads down, and then with the integrated design, which you're linking the buildings together, the peak demands could come down by nearly 50% is what we have been noticing on the project.
And then where do you see the gaps? Because you mentioned about some of the policies that are there, like ECBC and so on and so forth. So when you already have policies and when you already have the knowledge, why is there a gap in that is coming into practice?
So the challenge remains that everybody is thinking in isolation. Today, the energy is being thought in isolation. We talk about cooling as a problem, cooling as a solution. We talk about water is a different entity talking about it. The waste is a third entity talking about it. There is no integration which is happening. And as a result, you keep seeing that. Secondly, there's also a changing landscape on our projects, because since I'm a real designer who works on the project, works with the developers, the tendency is to break up the buildings. We are doing a large project for one of the developers here, 6 million square feet. Tendency is let's do 2, 2, 2, 2. There are 8 buildings that make a group of 2, 2, 2, 2 each. So each one is monetizable. So they can be monetized and looked at that. So I think there is a policy level missing. There is a bigger picture missing. Unless we put all of that together, we will keep discussing this. The real flight, which is what we need to do, will not happen till the time the bigger push is happening there. A larger integrated push is happening. And while we talk, I think 2 things which I like to mention here which are happening at this point. Bureau of Energy Efficiency is working on a ECSBC, Energy Conservation Sustainability Building Code, where they're bringing in, along with the energy, water management and waste management into the picture, looking at the larger thing. Similarly, on the National Building Code, the same thing is happening as we talk. The NBC is up for revision, where we are talking about an integrated design process, whereby these larger things, entities could become a reality. So district cooling has got a good future ahead, but it'll come with an integrated district energy solutions, not district cooling solutions.
Perfect, absolutely, makes sense. Thank you so much for that, Ashish. I'm sure the audience may have more questions. We'll come back to that at the end. And then just moving on, I'll start with Archa. You've been now doing development for some time already, looking at district cooling in India. So again, going back to the specific project, how would you go about planning, incorporating district cooling that is currently missing within the context of the current policy gap that is there? I think what Ashish said, if that happens, it's great. Yep. But till then, things need to still happen. You can't wait for policy for the market to move, right? So what would you go?
Sure. Can we have the slides up, please? So thank you for the overview, Sudhir, on the master plan. And just to do a quick recap, this is a mixed-use master plan comprising of about more than 50% of the area allocated towards commercial use, about 40% towards residential, and 10% towards public facilities such as healthcare and education. Why this is important with respect to this particular master plan is because mixed-use developments generally lend themselves very well to district cooling. Of course, taking into account other factors such as density of the building construction in the area, et cetera, which again, I think has been covered in the previous panels. With respect to this specific master plan, the way we thought of approaching this is through 3 interconnected district cooling plants, having supplemented by their own thermal energy storage tanks. And we decided to go this way as opposed to just having one single large district cooling plant, so that we can optimize the network costs, as well as allocate the plants, accommodate the plants within the area which has been earmarked for utilities close to electrical substations, again, optimizing the electrical infrastructure cost. Thirdly, it's important to have thermal energy storage, because I think Mr. Perry and a couple of other people have already covered how this can help with leverage time of day tariffs, as well as shave the peaks that we see during the daytime. In terms of the footprint, although these are 3 district cooling plants that we are talking about, we are still able to save an area of about 100,000 square feet as compared to standalone cooling systems that each building would have put up, which can, again, be monetized for either rooftop solar or for commercial activities. In terms of, again, for this master plan, another important aspect which has been spoken about as a challenge by, I think, officials from GIFT is ramp up. Usually these large master plans, about 1,000 acres or so, take maybe 10 to 15 years to develop and ramp up, which means a lot of pre-investment goes into it. But the way we are approaching it is in a modular fashion, which means that we'll put up the first district cooling plant, but the capacity will be suitable only for the first few buildings that are coming up. As more buildings come up in the vicinity, we'll keep expanding the capacity of that plant. Similarly, as and when more and more buildings come up near the district cooling plant, we'll extend the network, serve those buildings through this plant. Once it's about 70 to 80%, running at 70 to 80% capacity, we'll analyze whether it makes sense to further expand the network or commission a new plant, which will then be interconnected to optimize the capacity as well as build in the redundancy that is required. Can we move on? In terms of the specific numbers, again, this doesn't take into account what the passive design features that were covered by, or the integrative design approach that was covered by Mr. Rakheja, but only talks about district cooling as compared to the business as usual or standalone cooling approach. So I think we established in the baseline that the installed cooling capacity was about 150,000 tons. And with district cooling, because of the diversity benefits, we are able to bring this down by 40% to 90,000 tons. That's quite massive. And similarly, the capital investment comes down by 30%. So it's actually not more expensive, but cheaper. Similarly, for power infra, because of thermal energy storage, as well as improved efficiency, your peak power demand has come down from 170 megawatt to 65 megawatt. That's massive. That's 60%. That's almost 100 megawatts of reduction. And also results in savings for the SIDC. Otherwise, they would have had to set up the electricity distribution network, and for the developers, because they would have had to invest in the backup diesel genset systems, et cetera. Lastly, on the utility consumption side, there's savings on electricity consumption itself as well as water consumption because of improved efficiency and better operations by a provider whose expertise is district cooling. Yes, so the water saved is also quite significant, from 3.265 million liters with standalone cooling to 2.285 with district cooling, about 1,000 million liters saved because of district cooling alone.
Wow, so thanks for that, Racha. So now I think it looks like you combine what Ashish was talking about and what you were mentioning, both together. I don't know if, of course, some part of that will be offset by having more passive elements. You won't have as much of a benefit from district cooling for sure, but nevertheless, I think both need to go hand in hand, right? And the minute you have reduced mechanical load requirement and then aggregation of that load, so it's kind of contrary to, I suppose, what we've been hearing till now, where I think there is no problem of economics, there's no problem of life cycle benefits, nor is there a problem of basically sustainability benefits from this. It's just a question of planning, which unfortunately is a big challenge for us in India because of the number of actors involved. But it's about that coming together, and I think the new guidelines that you mentioned, if it starts forcing the market in that direction, possibly it could enable, from a cooling standpoint, right? Great. I'd just like to go on now to Prabhat, right? Again, thank you for highlighting the extent of experience you've had in the district cooling sector, and I didn't realize you've done so much, including for the breathe. So is there more that you'd like to add, for example, on what the challenges are for, first is on renewable energy integration. I think, does district cooling further benefit distributed renewable energy systems, number one? And then maybe from a building side, what are the practical challenges that you see from end users adopting a district cooling system?
So my take is that for a thing like district cooling to be successful in India, the developer community in India will have to buy into it. They should have a reason why they should go into it. You know, we can paint the world and doing this, that, and all, but unless they see that, yes, it makes sense to us, it's not going to fly. The second thing is that the policymakers are already busy with implementing certain policies on the ground, and district cooling has to merge in with that. You know, if district cooling looks at one particular point and the policymakers are talking about energy transition and energy efficiency and solarizing power, then how does district cooling help that? And how does it bring in efficiency into that? You know, till you make a case for that, the policymakers are going to say, okay, we are continuing with something, we'll look at it after we reach this. But if you look at it in detail, district cooling is one of the things which will help them in energy transition and energy efficiency. We all talked about thermal energy storages, which is one per plant. Take this thermal energy storage back to the buildings. That means you have a district cooling plant. The thermal energy storage is in the building. Where do you produce the thermal energy or the storage energy from? It is from the return water which is coming back without picking up sufficient heat from the buildings. So you're using the chilled water as condenser water, making ice at a in a very efficient way, and you are returning nice and warm water to the chiller plant and thereby increasing the efficiency of that. Today, the solar world, if it complains about something, it says that when we produce it, no one uses it. When we don't produce it, everyone wants it. Today, the microelectronics world and the intelligent grid, and leave alone that. You know, my sweet tooth is home automation. Because US and other people for security reason call it home automation. But it does everything for you which we are wanting to do to reduce energy in our buildings. It does digital inputs in, it does digital output, it can switch anything on anywhere. It does analog input. With a small thing, it'll give you temperature, pressure, humidity. The only thing that it doesn't do is analog output. Leave that out. But make use of that in order to do something practically. Now, you mentioned about backup DG power of 120 megawatt in a total of 170 megawatt. How long are we going to live with this DG power? This has got to go. Where are we using 120 megawatt out of 170 megawatt? In the air conditioning systems. No air conditioning system, unless it is life and safety related, should work on a DG set. It is the Indian developer industry which mentioned one line in their ads which said full power backup. And we are living with that. Some of us who live in condos which are 1.9 million square meters or something like that have 6,000 kVA of generators lying in the ground, out of which 10% works. And we keep paying year by year the service charges on that. So take that out of the equation. Everything, integrated design. You know, we are designing for the world today. We are not designing for ourselves. Ashish has done so many programs on BIM and things like that. I went to L&T recently. Every job of theirs is 10,000, 20,000, 30,000 tons. These kind of jobs they have for breakfast. Okay? Thermal energy storage, your TSE plants. Where does the water come from? Thousands of buildings being built. Unless you have an integrated TSE plant, do you think you can survive with every building with its TSE? Every building with its TSE in Gurgaon gets disconnected the first time the foul smell comes. You can see hundreds of them lying. So integration is the order of the day. Look at it intelligently. The Indian youth is far better in design as compared to, and you get it at the right price. So make use of that, make use of these technologies, and move on. There is no solution. That's my take on it. Thank you.
Sure.
I think very well put, Goel Sahab. I just want to add a comment to it. And I think the point came that who's going to fund it? Private developer is going to fund it. Not going to fund it. I think it has to come from the third party, which is what you guys are and many others in the market. Government is there to make policies. And developers are there not to run central cooling plants or central heating plants or central energy plants. That's not their job. You are asking somebody to do something which is not their job, and that's where we are going wrong. We have made every building today a powerhouse, a chilling house, a sewer house. What have we made of our buildings today? And we expect developers to comply and then get hanged when the things go wrong. This is not how it's going to work. It has to come from a third party, which is what it should be done. And the third party also should be looking at it holistically, which is what is missing. And I'll give you a right example where we were, one of the projects in Delhi where one of you guys was involved without naming them, arguing with the client on, I can supply the chilled water at this rate, you will generate the chilled water at this rate, discussions going on. Ultimately, why will you supply chilled water at this rate? Because I've got efficiency I'll be able to do. Client got offended that can I not generate the chilled water at that rate also because my cooling plant is also very efficient, and the talks broke down. Nobody said at that point of time, sir, I'll give you free hot water with that. Sir, I will give you energy demand which is reduced. Take out your that many transformers and that many generators. Nobody said at that point of time that, sir, the water for water where you don't have water, we cannot take out groundwater. City does not give us water. Where do we get water from? Tankers is what are getting us water in that city. Nobody said that I'm going to offset 10,000 tankers a day that you're going to require, put whole of it together. The day somebody has done that, I think there was not even a case where that developer would not have gone for it. I think that's what, to support what Mr. P.K. Goel is saying here.
So I'll just add a little bit to it,
Sure.
okay? How did Sheikh Zayed Road get sold in Dubai? You know, initially the Crown Plaza and all had their own plans.
That's right.
But as they made a master plan, they said, look, every air-cooled chiller you replace every 10 years, is the cooling demand going to go away from the Middle East? No, it's not going to go away. We need more long-term solutions rather than these short-term things that we are doing. And they made it in such a way that the developers over there bought into it. And district cooling is a utility. Mind you, I'm not a finance guy, I'm an engineer, a hardcore engineer, okay? But it happens that district cooling is a utility, and there are hundreds and hundreds of municipal corporations and other people who want to put their funds into assets that don't disappear. So this is for the finance people. And for the finance people, I'm to say I have a couple of points noted down over here, which I took permission to talk about. Sohini mentioned that penalty for non-compliance, okay? Now, it's a two-way sword, basically. It is the job of the district cooling companies to see that nothing comes on board which scares away developers. You know, as soon as you tell them penalty, they'll say, they will give us penalty, they are my suppliers. You find a solution by which, if you're not getting the water back at the right temperature, you use it over there and get your water back at the right temperature. You find a solution where at the initial 4 or 5 years of the project, you put 65-meter diameter pipes and you're feeding one building. You know what it means? Feeding air into this room from one side, and there is a small hole over there from where you are taking out air and trying to do some cooling. Okay, there are ways and means. We must learn from experience, and that's why I say the 45 years of experience counts. Thank you.
Absolutely, thanks. Just one last question before we move on to Michael and Sanjay. I think just sticking to the point on renewable energy, at least thankfully we are seeing much faster adoption. I agree that, I mean, we should not be solarizing the whole thing. There's too much focus in the energy conversation on supply, but not on demand. District cooling fits in well in the demand side, I completely agree. But just sticking to the conversation on the supply side, at least there is good increasing adoption of rooftop solar in the CNI space in India, right? There's fairly fast adoption happening. Do you see district cooling potentially acting further to provide that as a catalyst for that, in the sense, because like what you just mentioned, you have a lot of infrastructure on the roof. So what do you think district cooling can do for that?
The roof has to get freed up. I'm saying roof space is one of the costliest spaces around. Go to Bangalore, go to Chennai for that matter. They have complete roofs, available to you for a restaurant or whatever you have. So that's a huge value. And if you lived in Dubai and you had a 16th, 17th, 18th floor apartment, you would perceive that that is the costliest apartment going. Over here, the Camellia apartment sold for 100 crores, the top floor. Anyway, that story. Now, imagine if you take that apartment and next day you find noise coming from the roof. Are you going to live with it? No. So these are solutions, basically.
Sure.
And there are many things that it has to contribute. It is up to the provider to make it so good that the developer buys it and it works for the developer so that it sustains. The worst thing you can do is make the developer buy it, and then it doesn't work, and then the good old technology, it just goes to the dogs.
Clear, thanks for that, Prabhat. So I think let's just move track a little bit now to something away from cooling, and I thought probably Sanjay is a great person for that. And it's not the most sexy thing to talk about, waste, but nevertheless it's something which we live with, and because it's out of sight, out of mind, nobody talks about it, but I'd love to hear your perspective on just broadly the waste to energy sector in India, and then maybe Michael can help tie that in from a cooling standpoint, how it makes sense.
Can I have the slides, ma'am? Just to give a glimpse that even though India, if we see as a per capita generation of waste, is far below the global average, we are still generating about 160,000 tons per day, approximately 62 to 70 million tons of waste every annum. It's a sad state that only a small percentage of it is being processed. Our main emphasis is still on the collection part of it. And basically, it has a huge potential. If we compare, Kasturi Ranjan of Planning Commission had submitted a report earlier that we can go with more than 1,000 megawatt of power generation in 2014 from basically the combustible waste that is being generated from some 250 cities that he had. Then from few cities, 50 cities, having 250 waste to energy plants that could use that. So this is a good amount of energy that can be harnessed even after so much of impetus. Right now only we have 12 operating plant, where Delhi leading the show, followed by Telangana, AP, and Maharashtra. There are one plants. Still some of them are struggling, Jabalpur and others are struggling for survival. This is impact of open dumping, because maximum cases even till date, open dumping is taking place. And then now we are started remediating it. So basically the decomposed garbage is being again screened, and the combustibles more or less are being taken to a cement plant. In every petrol pump, we see a slogan that 1 liter of diesel generates near about 2.67 kilograms of CO2. Think of transporting so many tons of plastic that is being segregated, resulting into so much of CO2 that is addition, whereas the same waste in that vicinity of the city can be utilized to generate power and to further that power can be utilized elsewhere. So these are some of the obstacles that WT has seen in the country. There is no, it is basically seen as a power generation unit, not as a waste processing unit. There is no tipping fee or gate fee for the sector. We lack segregation of waste at the household level. Because of that, it has a very low calorific value, and plus, in our food habits, the percentage of wet waste is more as compared to international average when we see. There is a very strong NIMBY syndrome. Wherever you want to put up a facility, people will come that no, it is not possible. Nowadays, because of environment compliance, the capital cost for the project has gone up. And for this Rankine cycle-based waste to energy plants, you require a minimum quantity. Earlier, it used to be 500 tons per day. Now it is nearly 300 tons per day, can generate near about 5 megawatts of power. So WT can be considered or should be considered as a means for disposal of MSW also. And it has a huge potential for generation. Normally, the PPA is for a very long period, say 20 years, 30 years, whereas the dynamics change every 4-5 years. If we have a condition like the PPA can be revised after 5 years or so, or it can be revisited after 5 years, that will help in sustenance of these projects. This is some of, because we are very, I mean, as per statute goes, India is very well, there are too many laws, but on implementation phase, we lack. So coming to what the proposed 1,000 acres of the community, the development that is going to take place in Delhi NCR, even we take on a thumb rule basis, it will generate near about more than 300 tons of waste over there. So that waste can be utilized to generate power within that city. The disposal of that waste will be a problem because Gurgaon and even the NCR has a big problem for waste disposal, not adequate waste management facility. So this will add to circularity, that whatever waste is being generated from that community or the district, that can be utilized for generating power. And the waste heat of the steam condensate, that can be again utilized for district cooling. So that's what.
Great, thanks for that, Sanjay. And just one question before we go to Michael. So I mean, is there any regulation right now that prohibits having a waste to energy facility within an existing city limit? Why do we have dump yards that are so far away and so much of transportation of garbage trucks? For this community, for this master plan, if the developer is interested.
I don't think there is any restriction. There are some, the city boundary and other for the EIA, there are restrictions that you have to do. If it is co-located by the side of existing dump site, even EIA is exempted from it. So, I mean, the 2016 rules even permit that if it is by the side of the dump site, otherwise you have to go for a public hearing and a EIA.
Thanks, Sanjay. So I think so there's nothing that's prohibiting it from a policy standpoint. It's more about people not planning it. And now I think leads well into what Michael, so Michael, I think while Sanjay covered specifically waste to energy and the challenges in India, and of course, we have a long journey, unfortunately, on that part, right? But I mean, in terms of just integrating that with cooling, and if the base case of what he established was waste to energy is looked at as a power generation unit, the cost of power is of course higher than solar, as a result of which there is not as much adoption. But cooling can actually add a valuable element to change the economic case. Can you just cover both the technologies that are kind of in play right now outside India and also how that can work?
Yeah, thank you very much. There is a lot of interesting things that have been said in the panel, so it's a lot of different places to catch up on. I think I will start here from the end with the waste to energy. I think it's, we often actually hear that it is an opportunity to hit two birds with one stone, that both you're solving an energy issue and you're also unlocking, you can say, the or facilitating waste management by actually creating this business. So this is something that is definitely the case and something we see around the world. I will give some examples soon. But I think also going back to what Ashish said before, that it's not only two birds with one stone here. We can probably hit the whole fleet of birds by taking a holistic approach. Because starting with planning, I think what I heard before from the gentleman from Armstrong also, I liked a lot when he said that actually the district energy system as such is technology agnostic. And that's exactly the thing. It is actually something that is unlocking multi-source opportunities. All places looks different. There are different consumers, there are different resources, different conditions. There are so many things that are different. But we need to have this kind of district energy system in place anyway. Starting with that, we start to do the integrated planning. We look not only at cooling or not only at heating, we look at electricity, heating, cooling, water, waste, all the different utilities at the same time when we do this kind of planning. Maybe I can get supported with one of my slides in the meantime. We have spent a lot of time with, actually we are ahead, I would say, in the technology development, because the technology available in the market, they are great. This is definitely not a technology issue, I would say, to move forward when it comes to develop district energy schemes. It is more about actually sophisticated planning practices and making sure to broaden these skills. It's really important because it's very limited. I have seen not only that plans exist, but I mean to even go to sophisticated plans, integrated plans, it's very, very rare, I would say. I mean, we see a few countries. I think Denmark is a great example. Singapore is a great example, but that's about it, what we see actually out there. And again, coming back, I showed the picture before about the system analysis. This is exactly what is used when we do the integrated planning. We really have to simulate what is really, we saw examples even on the consumer level. And when we talk about integrated urban systems, not only energy systems, but systems, we have to start at the consumer side. Energy conservation, passive and active measures there, energy efficiency along the whole the system value chain, and that is for all these different kind of systems, water, wastewater, heating, cooling, and so on. Energy efficiency along the whole system. Energy recovery, as we have the district energy system in place, we also unlock the opportunity for energy recovery here, and energy symbiosis, sharing energy with each other. Integrating renewable energies. Instead of leaving the space free of noise on the top of the building, why not populate it with solar PVs, for example? I mean, all the rooftops that we are actually unlocking here with removing the cooling towers. Also to think about these hubs that we're looking at. Yeah, let me come back to that, but I mean to create co- and tri-generation hubs. And then we come to the system integration that I already mentioned. This picture shows pretty much what it's all about, the integrated urban energy systems. It's about that. And this also, when we talk about systemic efficiency, it is about integrated urban systems, but also to utilize energy and material in a circular manner. Again, energy symbiosis. It's really something we should do. If we can now, sorry, but put back the picture on the case study that you showed before with the 3 energy stations. It's very much reminding of a specific project that I worked on.
No. Just slide.
Tabreed the picture. In the meantime, while we go back to that, I can mention in Stockholm, for example, it is an integrated energy system. It is exactly like this. It is integrated water, wastewater, heating, cooling, electricity, and also gas. And the technology used there, we're using wastewater. It is waste management in place. It is waste to energy, producing power, heating, cooling as well. We have co-generation plants, we have tri-generation plants, we have district heating and cooling combined production we heard before, but with the heat pump chillers. We have carbon capture coming in now also, which actually creates quite some synergies when it comes to integrated in district energy, because carbon capture will need cooling, but that cooling capacity can also benefit the district cooling.
Correct.
Yeah, we can have a whole session about these things. Now, that was the case about Stockholm. I just mentioned some things. This one actually reminds very much about a project in Jinjiang. Maybe I don't know if Chen is still here, but just close to the capital airport in Beijing, Jinjiang, a new area. It looks very similar to this, where there's also 3 stations. And in these stations, it is the technology used there. So there is, in that case, it's not a waste to energy plant, but it is a gas-fired CHP plant in that case. And there that is passing by this area. So what they're doing in this station is that they are equipping them with heat exchanger for domestic hot water. They are there also, it's cold in the winter, so they also have a heat exchanger for comfort heating. They have absorption chillers for cooling, and also compressor chillers for cooling, and thermal energy storage. So it's really a multi-energy hub in 3 stations there, utilizing the heat as well from the power plant there. So, I mean, it's worth to look at. To say some percentages and so on is the boring engineering answer, I think. We really should analyze the situation,
yeah,
because it's
Clear.
really different from case to case, but I mean, the technology is there.
Understood.
It's really not an issue.
Great, great. Thanks for that, Michael. I think just in the interest of time, what I'll do is, given that we've covered quite a few diverse topics, and I'm sure all of you already know the answer, but just still to show that to you, we've kind of already quickly crunched some very, very high-level numbers to see what that might mean in this project's case. So just the last slide, and then we can probably open up for questions for 5-ish minutes, maybe. Right, so we just tried seeing how by including passive elements, including district cooling, including from...
Actually, I can just add one thing also. I think my colleague Sanjay is here also. I mean, we are looking into 2 ways to energy and specifically cooling plants now in India, so that we will study at the moment here in the coming months. So it's quite interesting. If there are any questions, just reach out to Sanjay. Maybe you can wave or something. Yeah.
Great. So I think so here what we tried doing is, again, just trying to see if we can pull these together and vis-a-vis the current baseline approach of not including some of these integrated planning aspects, what the numbers are. Like I said, cooling systems would be about 150,000 tons. So Ashish's points on passive interventions, if it's more widespread, could cut that by at least, you said 50%, but we took 30%, 50,000 tons. District cooling can further bring that down on an incremental basis with thermal storage by another 30,000 tons. Of course, renewable energy and more rooftop doesn't really change the cooling demand. And then waste to energy at this size for 100,000, 1 lakh people dwelling with 300 TPD capacity could give about 2,000 odd tons roughly. It's not big, but nevertheless, we're seeing the cooling mechanical capacity coming down from 1,50,000 to about 68,000 tons, right? So that's one level of impact. Economics, of course, is slam dunk, makes a lot of sense. Hot water is free, exactly, we did cover that. Power infra, 170 megawatts of substations, electrical infra across the board, and passive interventions cuts that by 55 megawatts. District cooling combined with thermal storage by 65 megawatts, with all the roofs free. If you just take only the commercial and industrial or the hospitals and so on, you, from having a lot of obstructed area on the roof, you have a lot more unobstructed free area. So the potential for incremental rooftop solar is about 20 megawatts. Waste to energy is covered as 4 megawatts. So like literally the cooling related power demand goes down from 170 to 26. So, I mean, in terms of our net zero vision and in terms of having, I mean, this kind of shows what the potential is. Water, again, like I said, I would love to have gone in a lot more into it, but in the interest of time, we couldn't. But just again, through passive measures and district cooling, you already are seeing close to a 50% reduction in water demand as well, right? And there can be a lot more that can be done. So this is the potential, and of course, I think what all of us would probably agree is this should be the progressive vision of an environmentally conscious India. not the siloed approach that we currently have, and I think it kind of fits in well. Now, I'll just probably have...
Can I just say one to that? Can you bring that screen back there? So actually, the reduction in water demand is not correct. The water requirement is 0, because the entire water will come from waste, from sewage.
That's
so
right.
we have actually made the whole project very viable. You reduce the fresh water, whatever the waste water which was going into the sewer line is actually being used now.
Absolutely.
For the cooling.
And that's the part we missed, but thanks for that. So I think, yeah, just we've not got, I think we've already overshot, but maybe some 5-10 minutes for questions. Ben?
Hi, thank you. It's Ben from UNEP. First of all, I think the integrated energy approach is fantastic. It's getting promoted, and from UNEP, we've been trying to make the case for this globally and in different countries. It's obviously extremely hard, especially on the waste side, bringing in waste. And already, if you're trying to make the case on district cooling, passive cooling, sustainable building materials, urban design, if we're bringing the waste as well, what's your perspective of developers getting, like, what's the actual appetite for this in India? And is it one step too far? And then second, sort of more towards maybe Sanjay, in some countries they've put efficiency levels onto waste incineration to drive the use of the waste heat, like Norway, for example. And that's spurred on the use of the waste heat for industry or for district heating. Can such a policy like that work in India, where you say, rather than having a 20% efficiency to produce power, you regulate them to have a 60% efficiency so they sell the waste heat? But seeing as all the barriers you raised, I'm a bit doubtful, but I'd just like to hear your thoughts.
If I got the question correct, you are saying that instead of power, which has a low efficiency of conversion, if it is used for cooling, it makes more sense.
For cogeneration.
For cogeneration, yeah. Naturally, it makes more sense. But right now, I don't think it is being used anywhere in the country. But it's a great thought that can be incorporated in the planning level also for projects.
Satish? Yeah, do you want to take that, Ashish?
So you also asked about the policy level. I think, how does that get implemented? Frankly, you cannot mandate such a thing on a project. Who will do it? And it comes down again to an independent agency, whether it's government, whether it's private, it doesn't matter. Somebody's successfully demonstrating it. Once that demonstration is done, there is actually a pilot running. There are environmental authorities, because every project of ours, a large one, has to go through an environmental impact assessment. And that's where they mandate these things to us. And the district cooling was also talked about it, but it is not getting that momentum because there is nothing to show as concrete that is doing that. So that's how the policy level would get implemented, because there's a lot of pressure on resources. I'll take a dig at Mr. Sanjay Singh, and we keep seeing, he showed you a number that we are smallest in terms of the waste generation per capita, and we are 1.43 billion people. Multiply that number, we are sitting on a heap of waste here.
Yeah, that's right.
Don't ever use the per capita
Sanjay?
for any of the indexes, because it just corrupts the thinking.
Satish?
Yeah, so I think thanks to all the panelists for wonderful interventions. I just want to make one point, and I have a quick question also. I think Ashish, Prabhatji, a lot of people talked about the virtues of integrated building design. My understanding is that it's not 30, 40%, but it's 3x, 4x between the best in class and the traditional design that is happening. And this is, you can take, like, if you are looking at how much square footage per ton you can have cooling. I mean, traditionally, the numbers that I was seeing, it was starting with 200, you can go to 250, 300, you can do 800 square feet per ton, 1,000 square feet per ton. You look at connected load, which will lead to lower size transformers. there are rules of thumb like 7, 8 watt per square foot or something, and we know that buildings are designed for 3.5 and 4 watt per square foot, and that cascades down, I think, in terms of all the benefits. Same things with heat transfer through the building envelope. So I think that if we really need to take an integrated approach, these things are possible. They have been done. Infosys has done for 50 million square feet, not for like one building or two building. That's what they do. But how do you actually bring all of that together before you start to size your cooling system and other thing is something that is sort of like my dream or vision when that become mainstream. The second aspect, which is the question, and maybe to Michael and others, is that one of the challenges that we have not addressed is that many times the developers, even though a lot of people say that these things can be done cost effectively, they don't put money because they can pass through all the utility cost, all the electricity cost to the, and that acts as a big barrier. We call it split incentive or principal agent problem. This problem goes away when the building is being designed for personal use or for its own use. How is that problem getting addressed? And Ashish, you are designing a lot of buildings. Tabri, you have done it in many other parts of. We know that Brookfield Asset Management and some of these people who are designing these buildings and they are going to own these buildings, they are thinking a little differently in terms of the REITs thinking and others. But to me, this is one of the biggest barriers to bring about this transformation among the real estate developers' mindset. So if anyone wants to have, I think, a response to that, we would love to, because we think this is one of the principal problems that we are facing.
Sure. Ashish, and I can also chip in after that if required.
So I think, Satish, you have been in the thick of it. You know, you've been around for so many years. You've seen the problem. I really don't know the solution, because until unless there is an assigned number coming, like we were hearing about Denmark doing a assigned number of total carbon being given to the buildings, right, from the operating to embodied, everything being talked about. Till the time we get to that levels, where we are assigning a number to a building, when a developer comes for a hearing, AIA hearing, or there is a code which is more performance-based, I think that's where the changes would happen. And we are getting there. I just want to say that also we're getting there, because for in ECBC, when we are revising it, when we are making the ECSBC, a lot of focus is on performance number. Now, can I push it to a ultimate performance? No, because, you know, market transformation takes its own time. And the cost economics need to be seen there. Even though I would personally believe that in a larger picture, it costs less to do all of this integrated design. Everything would be more there. But then we are not talking about everything be done in Bombay, Delhi. We are also talking about tier 3, tier 4 cities also. So looking from that perspective, I think we need to move there. We are on that journey, but possibly we are slow on that journey. But it is performance-based design that is what is going to make all the difference. Today, all our focus in last 2 decades of green building movement have been on design, 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 nothing on operational. We don't even worry about operation. Nobody puts the operational data on that. And once that operation number starts coming, the district cooling itself, district energy itself will start rising. You can see that number. So operational is the part that's missing.
There is building performance standards that many countries are adopting now, which starts to address the performance aspect. So I think the thought process is that the building energy code and other things need to be supplemented with a building performance standard. I think the budget that you are talking about, I think that's the next step.
So I can actually give a little bit more on that. In ISHRE here in India, we started this, you are aware of that, we started what we call a IBEEPS program, Building Energy Performance Standard Program. The biggest thing that we ran into, there's no data. Everything was being built into on the basis of models, and models were highly theoretical. There was no data of actual building that we could get, because it's not there, it's not mandated, nobody talks about operational performance, everybody talks about theoretical, and that's where the biggest challenges are. Because they are not statutory in nature. Until unless they're statutory, it cannot, nobody will do that. I will not disclose my building, he will not disclose his building. I like to believe I'm the most efficient, but I'll not disclose it to you. So until it becomes statutory, it will not. And that's why I'm saying this whole district systems come into picture when the operations, operational efficiency, when the things are in the open, I think that's where the whole push will come.
I can just add to that, and also, while of course regulation is one part what we're talking about, burden shifting, like you said, is a big issue, agency issue is a big issue, but a possible market-based solution to that essentially is through an outsourced solution, right? For example, I mean, a developer may not be motivated to really put in something because he knows that he'll just sell and get out from there. But if you have a cooling service provider, for example, like who does, because there the ownership of the asset is for the long term, then automatically, both in the way it's designed and the way it's operated, it's the market model that kind of addresses this issue automatically, right? So I think, I mean, in some ways, when it is siloed right now between somebody designing, somebody building, somebody constructing, somebody owning, somebody maintaining it, you always will have this thing being pushed around. But when someone takes a life cycle view, can take ownership for it, and for example, in terms of data, then the part you mentioned, we provide cooling now for 450 million square feet, right, for 25 plus years. So now if anyone wants at least that quantity of data, there's a fairly granular level of data for all type of buildings for 450 million square feet that can be put out there in the way that it makes sense. So that's the level of specialization that is required, which won't happen at an individual developer level. So it's both regulation plus also new actors coming into the play to do this.
I think one interesting change that is taking place, picking on what Sudhir said, is the changing mindset of developers. You know, earlier our thinking was, where we come from, what we build, we keep for our next generations. You know, that change in the developer mentality you can see. Now it is all about monetizing the asset, and you want the asset to be not only designed right, but performing right. So that change is happening, picking on what Sudhir said. Yeah.
Anyone else? Yeah.
I just wanted to know, is there any defined cooling density values which we can say that beyond which district cooling is viable?
Is there any minimum density?
Value or density or data, because see, it's a very subjective matter, cooling, district cooling, because it varies, because the spread of area and depending on the concentration of the cooling load, it can vary from places to places. Is there any subject or any value or as such?
Yeah. So I think it's a function of two things. One is how well are the buildings designed using passive interventions to minimize the mechanical load required, like Ashish said. It can even get to a point where probably like what Satish is saying, you may not even need cooling systems, and that's awesome, right? But I mean, keeping that aside, it's a function of course, electricity tariffs, and that varies from state to state and the mix and the development. But roughly, I think the rule of thumb that we work with for most states in India is 7,000 tons of cooling demand in about 1 square kilometer of an area, right? So I think we see that at least, unless proven otherwise, if that's the kind of demand in 1 square kilometer, it would be more cost effective compared to standalone systems. But again, case by case it varies. So I don't know if that helps, but.
So I have a question which extends a little beyond what we've talked of so far. So because in India, unlike many other developed countries, we have cities which are extremely crowded and which have developments which are very comfortable, and district cooling can benefit all the things we've talked about so far. So can we think of the possibility of the district cooling plants' return water being used to be able to cool a whole community of people who don't have cooling and who can benefit from it, and that would be able to lead to policies which come in to allow district cooling to come, because the density of such places is much higher than whatever district cooling you will ever do.
Yeah, great point, I agree.
Yeah, but the point is that return chilled water is also not free of energy. It has to be cooled down ultimately. So when it has cooled down, then you're selling energy to the cooling energy to the people. And it brings us back to those whole issues of mindsets and everything.
It's the temperature, yeah. It's the temperature, just bare thermal comfort.
I'm saying to bear the social cost. That thermal comfort is going to be very different from this. We can talk about it in the evening. It's a little longer question, but
it's a bigger issue.
That's the way to be able to justify district cooling in a society like ours.
Let's discuss over drinks. We have much more.
I think, I mean, can we go on, Satish, or there are more questions, or I don't know what time limit we have, but.
think
Yeah,
that
wrap up?
gentleman right
Okay.
at the back, he's been like raising his hand there. So, and his
This
question
is,
is not to me, it's to everybody else.
No, this question to Ashish. No, I think anyone who can help me understand things a little bit better. This is Rajan Raval from Sept University. Whatever understanding I have about economics, I mean, economics is one of the only thing which human has made so far. And whenever we start looking at economics, economy of scale definitely does help us, aggregation of demand. Just trying to understand that, and trying to understand from waste perspective, from any other parallels, whenever you start concentrating anything, whether it is a power or one solution, or even a waste, or even the way we supply our waters when we have dams versus we have a decentralized water harvesting systems. When you start looking at that particular understanding that you have to have decentralized generation, decentralized waste management, how far this concentration of single unit trying to feed number of floor spaces or houses, or an amount of waste we generate. I understand that people are talking about pushing the urban heat island outside the urban environment, but still there is going to be, we are not going to reduce the waste of heat coming out of that. Might be a little bit more because of the higher efficiency, but just trying to understand from that perspective that when you are trying to concentrate anything at one place, and generally the nature does not have a capacity to overcome that concentration on its own, how far are we going to deal with this district cooling systems? Thanks.
I'm not sure I got the question exactly right, but when it comes to recovering the heat from a distant place, we have been involved in many long transmission pipelines. What we are doing is that we are transporting the hot water to the central area to produce the cooling locally. Then we're talking about heating transmission pipelines of up to 100 kilometers. We're talking about transmission pipelines with several hundred meters elevation difference if required. There are technical solutions for that also. Dimensions of heating pipes of up to DN 1600. That is projects that we have carried out, is implemented, where it is heat recovery from remote power plants. Because this is the natural issue. It is that, I mean, there's maybe not a policy that says that you're not allowed to build a waste incineration plant close to you, but it is the dilemma of not in my backyard dilemma. Nobody wants it close to you. So, I mean, often they are constructed far away. Yeah.
You want to add something? Otherwise, let's wrap up.
So, I just wanted to show one slide on the same thing, this process of putting everything together and doing it in a separate way. If you can please put this. Okay. So here is a slide basically which shows that when you have a very, very large campus like what was being shown, certain parts come up first and certain parts come up later. That's the nature of the beast kind of thing. So here is what was tried out at certain places, that you have these kind of, they are not really temporary, but parts of the district cooling plant next to those two buildings which are going to get commissioned next year. You know, the chief minister and the politician has said, I just need these two buildings next year. Put the plant next to that. And when your entire thing is almost getting ready, shift these to a concentrated area. Why is shifting it to a concentrated area necessary? Say, for instance, city of Kolkata. I come from Calcutta. There is such a lovely river over there. You look at Hudson. I'm to say most of the major projects in New York, they get condenser water from the Hudson, and they put it back in the Hudson. Okay, there could be an environmental impact. They take care of that. But see how much of energy efficiency you have gained by not creating a demand for fresh water, first of all. Second, in disposing of that heat in a very particular way. So not all jobs are similar. Every job requires detailed analysis and thinking, but there are these kind of smart solutions. And that is what we engineers do. Thank you.
Great. Thanks for that, Prabhat. And I think in the interest of time, since we've already completely overshot, we can of course take more questions outside, but with this, I'd like to thank all the panelists for participating in this. I learned a lot, and I hope all of you did as well. And with that, I'd like to end this.